Welcome back. So, we'll continue our discussion on the demo on logistic regression, and we'll do the implementation with Sklearn functionality. So, before that, going to the actual program, let us have some initial discussion on this logistic regression functionality of Sklearn. Okay, so you can see the first line, it is the class of these details. So I am calling this instance of Sklearn, and there is a long parameter list. There are many parameters is accept, and most of the parameters are having some default values. If you want to know more, you can go to the particular page of this module and you can have the details, but I will discuss few of the parameters that should be useful for us. We should know those things. Okay, so one of them is solver. So you can see this solver parameter, it has the default value of this, and it takes this 5 possible values. So it is actually the algorithm that is used in the optimization problem. Okay, so it's the actual algorithm used, and for small data sets this leave linear is a good choice, whereas sag and saga are faster for larger ones. So we should know these values, because if we don't mention anything for this, then it will take the default value, and for different cases different algorithms may be useful. So it is important that we know what are the algorithms available, and based on our data set, the particular data set, we should select the appropriate algorithm, so that this functionality works the best. Okay, then comes for multi-class problem, only Newton CG, SAG and SAGA and LB FGS handle multinomial loss. Okay, so for multi-class problems we have to consider these algorithms, and then leave linear is limited to one versus rest scheme. So what is that one versus rest? So suppose you have multiple classes, but how this algorithm works means it takes one class at a time, and it assumes, like suppose there are class 1, class 2, class 3. So when I am considering calculation of class 1, then I am considering rest of the two classes as the another class. So at each iteration is kind of taking multiple classes, with one class as the one part of it, and rest of the classes as another part of it. Okay, so if this type of schemes are taken, then leave linear algorithm actually works. So these are the possible algorithms. Then comes this penalty parameter. So the purpose of penalty parameter is that it wants to make the loss as minimum as possible, means it wants to make the cost such a way that the actual outcome and the predicted outcome should be very close to each other. So for that this penalty parameter comes in picture. It actually does some normalization of the model parameters. Okay, so it takes these values L1, L2, elastic, net and none, and the default value is L2. It also has some specifications that when you have selected these solvers, then it only support L2 penalties, and this elastic net is only supported by the saga solver, and if none is mentioned, means none is not again supported by leave linear solver, and when none is mentioned, then no regularization is applied. Okay, so these things, it's very important that we know at least this parameter, the purpose of these parameters and the possible values, so that we can give always the most appropriate values for these parameters. Okay, when we are calling this module. Next comes max iteration. So we have used this earlier also. So max iteration is the maximum number of iterations taken for the solvers to converge. Okay, so here default value is 100, and we can change it. Okay, and we can try that how this algorithm is working for our implementations. Okay, then comes the toll parameter. So it also has the default value of 1 e to the power minus 4. It is the tolerance for stopping criteria. So stopping criteria is something, another concept that whether it will run for all the value of maximum iterations or it may stop at some point. So I'm not going in that much details, but this is one parameter which can mention the stopping criteria. Then comes fit intercept. So again it is the value of bias or intercept, that whether it will be added to the decision function or not, means whether I am going to involve this bias or not. And then comes class weight. Okay, class weight is something that for each class means each possible type of outcome. Then when I am calculating, then whether some weight value should be put with that or it should be none. So these are some parameters. Okay, okay, so this is SDG classifier, but first we will see that how I am going to implement this logistic regression with simple logistic regression. Okay, no gradient descent. So now I am in the Jupyter notebook. So in the first block of code I have imported all the libraries. So let us execute this. Okay, so here I am going to work with the IDs dataset. So we have already discussed about IDs dataset and we have used it as well. So if you are not sure, then you can go back to the IDs dataset session and you can go through that for better understanding. Okay, so here what I am doing, I am taking this data and targeting these two values x and y from IDs dataset. Fine, here I am just printing the first 5 records of x and y. So I can see that these are the values of this four parameters, 4 input features, and these are the outputs. Okay, and next what I am doing, actually this data set has 3 possible type of outcomes, so it you can say it's a multi-class. Okay, then I have splitted the data in something like the total records, 20 records, I keep it as the test data. So I have divided this x and y each in 2 parts. Okay, train and test data set. Okay, after that I am calling this logistic regression, and here I have sent few parameters. Okay, multi-class equal to auto, solver equal to this, c equal to this, max iteration equal to 1000. Okay, so let us execute this. Fine, with 1000 I will try. Okay, then it's the same way I am doing the fit method. I am calling the fit method so that it will fit, the learning will be done based on the training data set, and then in the next step I am going to predict the outcome for the test data set x test. Okay, and then comes the score method. So this score method, we are going to send the x test and y test, and it will check the predicted outcome and it will show me that actually the mean score kind of thing, that how close the predicted outcome is with the actual outcome. So if you can see that it is coming as 0.9, so you can say it is very close to the actual outcome. The predicted outcome is quite close to the actual outcome. Okay, you can change the maximum iteration values with some changes, and you can check that where the optimal thing is coming, that you can check with different values that how this score is differing. Okay, that actually tells us that how close it is. Fine, then comes these attributes. You can check once you have run these programs, then you can check these values. So first let me run it. So you can see first one is classes. So what are the possible outcomes of the classes value? So I told you that there are 3 possible types of outcome, that is 0, 1, 2, so that we can see. Okay, then n iter equal to 41. This is something that when the stopping criteria is mentioned, then based on some other values it takes the number of iterations taken for each class. Okay, so that's kind of a complicated calculation. I'm not going into that, but just know about it. And then coefficient and intercept, that you know. So there are, you can see 1 2 3 4 5 6 7 8 9 10 11 12 total these many coefficients values are present here, and then comes these three intercept values. So the coefficient value is kind of we know that there are four features, and there are three possible outcomes. So 4 into 3 12 coefficient values are there, and there are three intercepts, so that is related to how many classes are there and how many features are shared. Okay, then let us have some scatter plot. I will just try to see that how our predicted values means. So here I have taken only the first two columns of this test data set, and I am just uh, plotting it. So if you can see, okay, so you can see that these are the values. So here you can see the 2 and 1. So the predicted outcome, it comes as for these many inputs, it came as this 2, and here it is come as 1. So here I have plotted, again I have taken this x test and y test, and so here I have taken the predicted outcome. Here let us plot the actual outcome. So if you plot, you can see for the test data set, actually all the y values are 2. So here you can see that most of them are correctly predicted as 2, and only for two of the input set values, that it is wrongly predicted as 1. So that's why the score was almost 0.9. So it's very close. Only for two input set it gave wrong output, otherwise it is correct too. And this is actually the input. If you see the y test, you can see that in the y test all the outcome value is 2. So this is the I have plotted here x test versus y test, that is the actual outcome, and here I have plotted x test versus y prediction. Okay, so that is how we have implemented logistic regression algorithm, and now we'll see that how we can implement gradient descent with this logistic regression, that is again a Sklearn implementation. We have already used SGD regressor for linear regression, and this SGD classifier is for logistic regression. Okay, so this module also takes lot of parameters. Okay, and we can use this SGD classifier not only with logistic regression but other classifier algorithms like SVM, that is support vector machine. Okay, so here you know that regularizer is a penalty added to the loss function that shrinks model parameters toward the zero vector. So that is the work of penalty. It's kind of normalization activity that is being done, that we have already discussed, and then the gradient of the loss is estimated each sample at a time. That this is actually stochastic gradient descent. We have already discussed different types of gradient descent as part of a linear regression demo. So this stochastic gradient descent, it takes one input at a time, you know, so it takes each sample at a time, and the model is updated along the way with a decreasing strength schedule on learning rate. So you know that based on the learning rate, it decides that what will be the rate of change to the input parameters and how it affects to reach the global minima. So if you have any doubt on this, so please go back to that. I'll do that session and have a look into it, so that will be more clear. Okay, and this module also takes lot of parameters, so I will discuss few of them, and many of them are similar to logistic regression, so will not touch those. So I'm going to discuss some of the new things. Okay, so first of all is loss. So it's a string value, it accepts string, and the default value is hinge. So here, as I told you, that this SGD classifier can be used for many different classifiers. So in case I want to use it for logistic regression, the value should be log, and if it is being used for support vector machine, that's another algorithm, then we should go for hinge. Okay, then there is another argument that is shuffle. You know that in case of stochastic gradient descent, as one sample at a time is taken, so if shuffle equal to true, so the training data will be shuffled every time. Okay, then comes the learning rate. So the default value is optimal. There can be different learning rates, different functionality actually is there. So it can be a constant value, it can be in scaling, it can be adaptive. So there are some different logic for calculation of learning rate depending on the value we supply here. Okay, then comes another parameter, early stopping. By default it is false. So it is to terminate training when validation score is not improving. So there is a concept that if we put it as true, then what happens that the entire training data is not used for the model. It keeps some of the part of data as validation data, and when the training is done, it compares the validation data with that, and then if some criteria is met, then actually it stops the process. Okay, so there is some detailed logic is there, but only thing is, if we want some early stopping based on some validation, then this parameter can be set. Then comes this validation fraction. So it is like, as I told you, that some of the part of training data is kept as validation data. So this is how the data is split, means the proportion of training data set aside as validation set. So that is that fraction of validation data. Okay, so that those are the different parameters for SGD classifier. Okay, now we'll go back to Jupyter notebook and we'll have some demonstration on the same. Okay, so here I am importing this SGD classifier. Okay, and again I am loading this iris plan data set in this X and Y. Okay, so you can see that the shape is something 150 by 4, total 150 records, and each are having this 4 columns for this data part. Okay, so there is one concept that how much max iteration value should you take in this this algorithm. So there is one logic that you can take like that based on your number of features you can calculate this value. So it is np dot cell 10 to the power 6 divided by 4. So this 4 is something, this one, the number of features. So you can say this is value, this is one value that you can take sometimes, means is some clue, you can say that how much max iteration value you will set. So that gives you some clue. Okay, so now I am splitting the data again in X train and Y train, X test and Y test. Okay, then I am calling the classifier with loss equal to log, because I am going to do logistic regression. Then maximum iteration I have kept it as 1000 for now, let us see, and this is the TOL parameter, this is anyway the default value. Then I am doing the fit method with X train and Y train. Okay, so you can see these many parameters are there, and now I have set only 3 parameters values, so rest are actually now populated with these default values. Okay, then I am going to do the prediction. Okay, so if you see the score, oh, it's so less, so let us try with this value. Okay, initially I will just increase this to something 20,000. Okay, let us check. So it's better. Okay, so I'll do it again, the data. So I can say that I got a much better score. Now it is 0.95, and let me try with actually this value 25 and then 4 zeros. Okay, so I will again take the data. Let me go with this max iteration value. See how much. Oh no, it decreased, so actually that was not the appropriate value. Better I go with this value only. Fine. Okay, so now I got actually it is like the exact value. Better we go again x and y calculation. We'll take some fresh data set every time. Okay, so it actually gave the correct one. It's 1, that means all the values are predicted correctly. So if you see the values, so here also I have the same thing. This coefficients and intercept is the same logic. So intercept, 3 intercept values, because there are 3 classes, so for each class there is 1 intercept value, and coefficient also for each parameter there is a coefficient, and for each class as well. So it's like the number of parameters is number of features into number of classes. So here it is 4 into 3, 12. That's why you have 12 coefficients. Then there are some other attributes as well, that also we can print. So this is the number of iterations for each class that was taken. Okay, and then this loss function, so this is the name of the loss function that was used. So this is the log, because we have sent that, and then this is the classes, that is 0, 1 and 2. Now let us try to plot. So first thing I am plotting x versus y pred, that is the predicted value, in blue color. So you can see that all are 2, because we got the score as 1 anyway. And now I am I'm plotting the test y test, that is the actual outcome, and here I can say that everything is 2. So here actually in our scenario we have predicted everything correctly. So you can see that this how this calculation actually is helping me to get closer to the actual number of maximum iteration I can start with, and then I may have to change it based on the outcome I am getting. So that's how I can use this stochastic gradient descent classifier algorithm for doing the logistic regression. And here I am trying, or almost here actually we have made the cost 0, because everything was predicted correctly. So the purpose is that by changing the number of iterations and other parameters, we can go to the most efficient and most correct prediction, okay, that we can generate with logistic regression. So here we complete the demo on logistic regression. So just to summarize, so we have seen the implementation of these 2 functionalities. One is this logistic regression, and another is this SGD classifier, and we have some very initial discussion on the parameter list of these 2 modules, and you can always go to the Sklearn documentation and you can see the detailed discussion on the parameter values and their significance. So we complete it here, and in the next session we will going to discuss different algorithm. Okay, for now, thank you.